probability. Chance is to do with the likelihood or probability of events occurring. So if I type that in here, chance is the likelihood or probability of something occurring. We hear statements involving chance nearly every day. For example, I am almost certain that I passed the exam, or it is unlikely that I will make the movie tonight, or we will probably move next year. All of those statements, certain, unlikely, probably, are all different versions of probability or chance. When we talk about chance, we can pretend that we're running an experiment. Some of you may have remembered that I've talked a little bit about theoretical versus experimental probability already. But we can, if we talk about running an experiment, we can assign numbers to chance based on those experiments. When we deal with chance, we are talking about an event. An event occurs when we obtain an outcome with a particular property. Okay, so occurs when we obtain an outcome with a particular property. Outcomes, then, are the possible results from running an experiment. What do I mean by running an experiment? Imagine that you are rolling a dice, or a die, which is one set of 2 dice. The possible outcomes would be that you could roll a 1, a 2, 3, 4, 5, or 6. The particular property here would be that the event, an even number, occurs if we get a 2, 4, or 6. The same could be said of the odd numbers. If an event cannot occur, we assign it a number 0 or 0% chance. For example, to roll a 7 would be impossible, so there is a 0% chance of that event occurring. If the event is certain to occur, we can assign it the number 1 or 100%. For example, the chance that the sun will rise tomorrow morning is 100%, or 1. The chance of any event occurring must fall between 0 and 100%, or impossible and certain. Events that may or may not occur with equal chance are assigned the probability of 0.5 or half, meaning that these type of events have a 1 in 2 chance of occurring. For example, flipping a coin. It can either be heads or tails, a 50-50 chance. When you're talking about a coin toss being 50-50, we are using theoretical probability. The mathematical construct of what we theoretically expect to happen. Okay? Experimental probability then is what happens when you actually do the experiment. Okay? So we may expect that in 10 tosses we would see 5 heads and 5 tails, but when you actually toss the coin, you may see 3 heads and 7 tails, or 6 heads and 4 tails. It could be different every time you do it. So that's the difference between theory and experiment. Theory is the math behind what says should happen. Experimental is what happens when you actually do it. When you perform the experiment, you count the frequency with which a particular outcome or event occurs. Okay, so the number times a particular outcome or event occurs. For example, if you toss a metal nut is one of those things you screw around a bolt, in the air 50 times and it lands on its flat side 41 times and on the edge 9 times, the frequency of the nut landing on its flat side would be 41, and the frequency of the nut landing on its edge would be 9. The relative frequency of the outcome or event is the frequency divided by the number of trials. Okay? So if we look at this table right here, we look at our outcomes, that it can land on its flat side and its edge. The frequency, as we mentioned, was 41 times it landed on the flat edge, or the flat side, and 9 times it landed on its edge, for a total of 50 times. The relative frequency then is 41 divided by 50, which equals 0.82, and 9 divided by 50, which equals 0.18, for a total of 50 out of 50 times, which equals 1. So as we know, these are decimals, and we can convert those into percentages by just moving our decimal spot 2 places. So this would be 82%, 18%, and 100%. So the chart we just created is called the sample space. It represents a set of possible outcomes of an experiment. If we look at our die again, our sample space would be 1, 2, 3, 4, 5, and 6. The probability of each number being rolled is 1 out of 6. So if we ask, what is the probability of rolling a 2, the answer would be 1 out of 6. If we ask, what is the probability that we roll a 2 or a 5, the answer would be 2 out of 6, or 1/3, because remember, we always simplify our fractions. So our sample space then represents the set of possible outcomes of an experiment. Okay? So, as we mentioned up here, I've shown you 2 ways to express probability. We can express it as a fraction, and we can express it as a percentage. This is obviously in a decimal form, but if we were to turn that into a percentage, it would be 82%. Okay? So the third way that we can do this is as a ratio. So if we go back again to our dice, so if we have a fraction, which would be a 1 in 6 chance of rolling something, our percentage would be, so if we round up, it would be 17%. And as a ratio is really easy to figure out. You just take your fraction, so 1, but instead of the divide line, you use a colon. So 1 to 6 would be our ratio. So if we were to do the 2, if our fraction was 2/6, or as we know, because we're going to simplify it, 1/3, then that would be 33%, and our ratio would then become 1 to 3. Pretty straightforward stuff. If you have a 0% chance of something, the fraction would be 0.6. On a dice, for example, something that would have a 0% chance of happening would be to roll a 7. So if we said, what is the chance of rolling a 7? You can't. It's impossible. So it would be a 0%, or 0 out of 6 chance, or 0 to 6 as a ratio. If we said, what is the possibility of rolling a number? You're going to roll a number when you roll a dice, so that has a 100% chance, so that would be 6 to 6, or 1 to 1. So let's take a look now at a spinner. And there are 5 different colors here, so the probability of getting any one of the colors would be 1 to 5, or 1/5, or 20%. That's the theoretical probability. If we were to actually spin it 5 times, it's unlikely, there's those probability words again, that is what would occur. Let's see what happens. So, we'll spin. And we got red. Spin again. Purple. Orange. Green. And red. So almost we met our theoretical probability, however we hit red twice instead of getting a yellow. So it doesn't always line up with our theoretical probability. However, it would make sense that the more times you spin, the closer you would get to the theoretical probability. If we took a look at this and we said, what is the experimental probability that we rolled a purple, we would say 1 in 5. Same with green, 1 in 5. Same with orange, 1 in 5. But red would be 2 in 5. And yellow, 0 in 5. So that's the difference between our experimental and theoretical probabilities. Please take some notes. All this is very important. On tomorrow's class, we will actually look at some of these problems and try and figure some of this stuff out.